So anybody who's ever used Python and C knows that Python is much easier to use than C for a lot of things. And frequently Python code is also a lot more simple. And one of the reasons that's true is because of these things called list comprehensions and the map function. So if you have just a list of elements, Python has this really nice notation where you can do things like, well, let's come up with a predicate. So we might want a predicate that returns true if a number is odd, let's say. And we can define that as just return x mod 2. Okay, so that's a function. Let's say we want to select all the elements in this list that are odd numbers. So in C you'd have to declare another array, and you'd have to declare a repeat loop and a counter variable. But with Python, there's a notation that lets you abbreviate all that, and you can just say A for A if is odd A. And using the predicate that you defined that just automatically picks out the odd ones, this is really more. This is a list that is in a different memory space, and so it's there are two objects here in memory. This isn't really just a transformation of the list that existed, but so I want to show a way to do that in C. Also, in addition to doing real comprehensions, you can also do transformations. So, what if you want to know the truth value of the isOdd function for all the a's in the set? You can do this. Another way to do the same thing is using the map syntax. So that means apply the transformation isOdd to every element of A, and you get that. So I'm going to implement list comprehensions and maps in C, and I've written some code to do that, which I'm going to show off here. So I have a dynamic array, and I've already done one tutorial on dynamic arrays using structs, and if you're going sequentially, you've already seen that, and I've alluded to this other one when I did the first one. Now I'm using the void star type to represent a list. And because I'm using void star, I need to store some auxiliary information about the number of bytes used for whatever type it is that void star is a placeholder for. And this is a little bit complex, but the payoff is that now I can use the same code for a list of strings and a list of floats and a list of ints. It doesn't matter. And I'll give a couple examples of using this, one for integers and one for strings. And this is probably familiar. So this is just the amount of memory allocated to the dynamic array, and this is the number of slots that are actually used. And there's the definition of so now dar is shorthand for struct dar. And these are the functions which I have defined here in the .c source code file, and I'm going to go over those now. So here is the grow function. So if you remember, just in general, what grow does is when a dynamic array runs out of memory, then you double the amount of allocated memory and copy everything over, and then free the memory from the old thing. So that's just exactly what I do here, and I make sure that that this isn't going beyond some kind of maximum value. I forgot exactly. This is the biggest number that allocated could possibly be, or something like that. Anyway, this is just error checking. So allocate twice as much memory as you had before. Notice that the size of elt comes in here. So if this is a list of floats, this is going to be 4. If this is a list of ints, it's going to be 4 on my machine, but if it's a list of doubles, then it's going to be 8. And so it just makes sure that the right amount of bytes gets allocated. And of course, memory allocation can always fail, so you should check for that. And now this is, remember what memcopy does is just copies bytes. It copies this many bytes from this memory location to this other memory location. So here you can see this is what the list was before this new allocation, and this is how many bytes to copy. So I just copied the entire list. I could change this allocated to used, and that would actually make the code faster. I should probably do that, but this is fine. Now free the memory for the old list, make the old thing the new thing, and update the database to reflect the fact that you now have twice as much memory allocated, and that's success. So this is a function I wrote that just prints out the dynamic array as what it is in hex. Like if you just looked at the memory that's allocated to it in a hex editor, this is what it would show. So before you do anything, you can't dereference a void star type, so you have to typecast it to char. And then you just go through and look at every single char in hexadecimal format. So no big mystery there. This is mostly just a debug function that I wrote to make sure everything was working okay. And so this is like the Python append method. And so everybody know what that means. So let's say you wanted to add a new number to A, then you can use the append function. It sticks it on the end. So that's exactly how this works. It sticks it on the end of the dynamic array, and so it's got to take a dynamic array as input. And I don't do any error checking here to make sure that D is not a null pointer or something crazy like that. It probably should, but I don't. And this is the new thing to put on the end. And so this is just the stuff that makes sure that there's enough space. So if there's not enough space, then you have to grow. If growing fails, then abort the entire program. That's what that says. Now this is a little weird, and the reason it is weird is because we're doing void star types. So I have to do a memory copy here, and I need to find a place in memory to start the destination of the copy. This is going to be the origin of the copy, and so this will just be like a float or something. But because it's a pointer, it'll really be the memory address of where the float starts, or where the int starts, or where the double starts, or whatever. So it'll copy this many bytes. So if it's a double, for example, this will be the memory location of where the double starts, and this will be 8, and then it'll copy 8 bytes from here to here, which is what you want. So where does this liloc weird thing come from? So this is the memory location of where the dynamic array starts in memory. And now you want to add to that the number of used elements times the size of an element. So this is just like a pure memory location. And this is where you should copy this information to effectively put another thing on the end of the list. You can't use the more natural subscript notation. What I'm saying is you can't do something like li blah 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 equals ja ja ja. The reason is because that's implicitly dereferencing, and you can't dereference a void star. And now you've got to update the database to reflect the fact that you have more elements now. And so here's how I implement the map. And you can see that it takes a function pointer for the actual map function. And so there are several ways you can do this. I kind of explained my scheme here. So the first input to the transformation function just stays constant. That's like the input to the map. And this gets changed inside the function. When you pass a pointer to a function, changes can happen inside the function, and so it changes this to be a certain transform of this. So this one is constant, this is like the domain, this is like the range. After you apply the function, what this is the transformation applied to this input. And it needs to take some dar as a dynamic array to operate on. And this is going to be the result. So you have to allocate memory for the result. It's going to make sort of a new structure, just like Python implicitly does. And so this is basically just making it sort of a copy of D, at least in terms of memory allocated. And now you need to go through and actually do the transformation, and that's what this does. And then you just return this new thing that you've constructed. And so the effect of all that is like applying the Python map function. And so here's how I do list comprehension. It's a lot like the map function, except this this prototype for the function pointer that gets passed in, it returns true or false. It's just like when I did the list comprehension in Python, we call a function that returns either true or false. Sometimes we call that a predicate. So when you do list comprehension, you should really use a predicate, and the ones that are selected are the ones that make the predicate evaluate to true. And that's why I have this function prototype returning a bool, because a bool is either true or false. And so what this is going to do is it's going to make a new dynamic array E. What E is going to contain is exactly the elements of D that make this predicate evaluate to true. And so this first part is just copying over what D already is into this new thing E, which is going to be the dynamic array pointer that gets returned. And now you just go through and you check the predicate. Now we've got to, again, it would be more convenient if we could just do D stabs li I, and the problem is if you do that, then you dereference a void star and it doesn't work. So what you have to do is do it in this sort of crafty way where you're pointer hopping out to the right location in memory. So this is the location in memory that you want. Here's the start of the memory location where the list is, and you go I times out however big an element is, and that gives you the correct memory address to pass to the predicate function, which evaluates to either true or false. If it evaluates to true, then you go ahead and append the thing that you were considering to the new guy, and then after this goes through once for every element that D contains, you return the result. And so here I've just made up a couple sample transformations for debugging to convince myself that my program works. So all this transformation does is it supposes that the type of the dynamic array are chars, and the transformation is just increment by 1. And this is a sample predicate. It's the is_odd predicate. It's pretty much exactly like the Python code. You've got to do typecast, of course, before you can actually do any kind of manipulation, which is what this first line is. And so this is an initialization function for a dynamic array that you want to represent just character values. So that's not strings, that's just chars. And here's a sample main file, and I put a T in front of it just so the compiler won't consider this function to be the entry point, because I have another sample main file down at the bottom that I'll get to in a second that I actually want to try first. And so this is an initialization function if you want the dynamic array to store strings, and there's a couple of assumptions here. I could maybe make these parameters. The assumption is that the strings are going to be at most 50 characters long, and this is the initial amount of memory allocated to the dynamic array. So I just made up both of these numbers. Could take them as parameters to the function if you want. This just prints out, it's just a debugging function, so it prints out your dynamic array assuming that it contains strings, and yeah, so it doesn't inherit this assumption or this assumption, so it's pretty general. If you change those numbers, it won't break the print function. And so here's a sample transformation to test my code to make sure it works in this case, and all the transformation does is it makes the string uppercase. So first you copy the domain into the range variable, and then by pointer hopping I go through this string, which is just an array of chars, and I convert each character to uppercase character. And here's a sample predicate for testing list comprehension for a dynamic array that is intended to store strings. And the predicate returns true if the string starts with S and returns false otherwise. So here's the main function that I want to test, and that's for the version of the DAR that stores strings. So initially you can see the output here too. So here's where I initialize it, and then I make a few strings, 3 strings here, and I just append them, and after I append the first 2 things I print it out, and that's what this line is, and then I append another thing, and then I check that, and so here we are. This is after line 190. That's the output there. And now here's the transform that I'm going to try is the transform that makes everything all caps. And so I need another variable to store the result of that because it returns a copy, remember. So it applies the transformation. Here's the dar map function. Here's the transformation getting passed in. And here's the original dar that you want to operate on. So it produces this result m, and now we look at it, and the output is here. So you can see that it's worked. The transformation has indeed turned every string into uppercase version. And now let's test the list comprehension part. And so for the list comprehension part, I need a predicate, and the predicate I'm going to use is my starts with s predicate. And of course I end up with a new dar here because it returns, allocates new memory and returns a new thing. And so what it's going to do is select out all the strings in here that begin with s. And so the effect of that is just going to be to throw out this middle one. And you can see from this final output statement, which comes from line 197, this final output statement shows that function works. Alright, so that proves that it's good for storing strings, but let's go back and use this other main function. And what does this other main function do? It assumes that the dar is just going to store chars. And it starts out with these 3 bytes. And so let's compile it and see if we can figure out what it's doing. Okay. So here is what the dar initially contains, and you can see from this initializer, all this stuff up until here is just initialization that I probably should have put somewhere else. And then this first print statement is creating this output and this output lets you see that the content of the dynamic array is just these 3 bytes. And now I test the grow function and print the result, and so you can see the effect from here to here is that the number of allocated slots has doubled, which is what we would want for the result of the grow function to be. And now we're testing the append thing, so make enough memory for one new character, it's going to be D, and let's try appending it and then print the result. And everything worked well, so the number of used goes up to 4, and now it's got these 4 things in it. And so now let's try the map, and the map is going to be this. We went over that function earlier, it just increments every member by 1. So apply the map and then look at the result. And you can see that indeed every hexadecimal or every byte has been incremented by 1, and so that works. And now let's try the list comprehension, and we're going to select out the ones that are odd. So apply the comprehension and print the result. For some reason so I apply first to D, which is the original thing, right? So which one is D? Okay, so E has already had the map applied to it. So this is E, and this is D. And first we apply the predicate to D to get F, and that selects out these 2 things. And is that right? So what is A in hex? A is 10, which is even, and B is 11, which is odd. Check. And so similarly, this is even, this is odd. So that works. And now for the same reason, when you apply the comprehension to E, which remember is this guy, you get this output, which again is exactly right. And the allocated and the used values are also correct. So that's all the testing I did. But now with this code, I can do these kinds of list comprehensions and transformations just like in Python, which will save me a lot of work in the future, hopefully.